All right, section 3.5, savings and annuities. So we have a couple of new formulas to look forward to. But the good news is you don't have to memorize any of these formulas. You just have to know when to use what, which will take some practice. But anyway, part of smart financing is finding low interest rates on loans. But on the other side of that is getting high interest rates on investments. The simplest form of saving money and collecting interest is a savings account, which you may have along with your checking account. Pardon me. The interest rates for saving accounts vary, but are usually around 1 to 5%. As college students, you may just be trying to get by, but at some point you will start to think about saving for retirement, and that's where annuities come in. The better known ones are 401k and IRA plans. So what's really important about annuities, besides this formula up here, is that deposits are made regularly and on a same schedule. So you're making a deposit every month, every year, every 3 months. The deposits are always the same, and annuities have many deposits where compound interest investments have just one deposit. So I talked about the couple that was saving money for college, and they had to put this huge amount down in order to do that. With an annuity, they could just put a small amount each month to work towards their goal, which is much more doable for most people that don't have a bunch of money sitting around that they can just put in an account to sit there. Most of us need our money to pay our bills. So we have an equation here, and the only thing, there's not really, I guess the new thing is the D. So this is the regular deposits. So that's a completely new variable. The rest of it we've all had before, but just to confuse you, no, I'm sure it's just standard practice or whatever. N is now the number of years instead of T. So it's like T. And now K is the compounding periods. So that's like lowercase n. So now capital N is the number of years, and there's no lowercase n, but K is a compounding period. It's like lowercase n. So R is still your interest rate, and then P sub n is the balance in the account after n years. So that's like your future value. Okay. So let's do an example and get some practice with this. Which one of the following best describes an annuity? Check the correct box. A lump sum, no, because we talked about how it's deposits. Deposits that are made at random whenever you have extra money, no. The deposits have to be regular. Equal regular deposits that are made into an account earning interest. Yes, that's the one. That's what an annuity is. That's what distinguishes it from the other problems that we've been doing. So example, you deposit $1,000 each year. So that right here is screaming annuity. So later on, when you're presented with all these problems in one assignment, keep in mind that an annuity is when you have equal regular deposits. You deposit $1,000 each year into an account earning 4% interest, compounded annually. How much will you have in the account in 35 years? So we'll plug that into our formula. Make sure I use the right letters. So it's P sub n is equal to big parenthesis And then I'll draw a line so we have a top and a bottom. So it's parentheses 1 plus 0.04 over 1, parentheses raised to the parenthesis 1 times 35, and then in the bottom it's 0.04 divided by 1 again. And then over on the side I have what it looks like in Desmos. So to get that, you'll want to type 1000 parenthesis and then type the fraction. So the fraction button looks like A over B. So that'll give you a top and a bottom. In the top, you'll put parenthesis 1 plus 0.04 divided by 1, close the parenthesis, and then go into exponent mode, parenthesis 1 times 35 parenthesis. Then click down into the denominator to do 0.04 divided by 1 again. And when you do this, well, I have to do it because I have a screenshot of it, but I don't have it on my screen anymore. So I'm putting it in right now. You can put it in with me. You know what it's going to look like. Lots and lots of parentheses. And even though we're dividing by 1, I'm still going to put it there because later on when I need to change it, it'll be there and ready for me. Same with 1 times 35. We know what that is, but putting it in there will help for using it again and changing the numbers. Okay. 1 plus 1. Oh, there's a -1 in there. Did I forget that in here? Oh no. In my screenshot, I missed the -1. Sugar. All right. Well, in that case, I'm gonna, yeah, that looks better. I'm gonna go into Desmos on here and we can do it together. All right, I'll just hit enter to get out of whatever that was. So 1000 parenthesis fraction button, more parentheses, 1 plus 0.04 divided by 1, right arrow, close the parenthesis, exponent, parenthesis 1 times 0.35. Wait, no, just 1 times 35. Close parentheses, then -1, all over 0.04 divided by 1. So you should get $73,652.22. I don't know why it does that to me. It changes, my notability goes away. That's how much you'll have in the account after 35 years. Okay. Yeah, and I have down here the Desmos directions, which I'll be updating because you need to put -1 here. I left that out. And then here it's showing it in Excel. So you can type everything in Excel, put the $1,000, the interest, how many compounding periods in the years. And Excel will tell you that the future value is the same as what we got, $73,652.22. And then the amount invested, you can get that by multiplying $1,000 times 1, because it's just one time a year, times 35 years. So that's 35,000. Which means if you subtract those two values, you get how much interest was earned. So it's a lot of interest. It's over $38,000 in interest. And for this problem, we use savings account area because we want to know the future value of our investment, as opposed to knowing how much needs to be in the account to receive a specific payout. So if you're just trying to figure out the future value of an account, you can use this savings account area in Excel. And also the savings annuity formula. That's one thing about doing it by hand that makes it a little easier than doing it in Excel, because there's 3 different boxes in Excel that you can put these types of problems in, and you have to know which one is which. All right, example B. Suppose you have $600,000 for retirement, or you want to have $600,000 for retirement in 20 years. Your account earns 7% interest. How much should you invest each quarter? How much total will you put into the account? All right, so this is different from the one we just did, because this one we want to know, or we have the future value, we want to know how much we need to invest. So we can use the same formula, but it's going to be set up different. It's going to be $600,000 equals, and we don't know what the D is, the payments. So D and then parentheses, make a fraction, 1 plus 0.07, because it's 7% interest, over the compounding period, which is 4, is because it says each quarter, so there's 4 quarters in a year. Close parentheses on that, and it's going to be 4 times 20. And then minus 1, which is what I was missing in the last one. And then 0.07 over 4. So for this kind, we have to take everything that's in the parentheses here that I highlighted, put that in Desmos. So I'm going to do that right now. So since I already had most of it in already, I can just edit it. I took out the 1,000 from last time. And then I'm just changing all the numbers to make them match what we have on our paper. So I don't have to type it all again. So I got 171.79. Oops. Let's go back to pen mode here. And of course that's rounded, and I can round on my paper, but not in the calculator. So then I'll do on the next line, 600,000 divided by ANS for answer. So it takes that whole thing, 171.79, 38242, etc. And we get $3,492.56 when you round. Those are the payments that you have to make. The amount needed to invest each quarter to make the goal. And then it says, how much will you put into the account? How much total will you put into the account? So for that, you have to multiply the answer we just got without rounding times 4, because it's 4 times a year, and then times 20 for 20 years. So I'm going to hit enter here and then do answer times 4 times 20. And that's $279,000, $279,404.69. And you can see that doing it in Excel in the savings annuity future value unknown section, you put in the $600,000, 7%, 20 years, 4 compounding periods, and we get all the same values that we just got. Well, we didn't calculate interest, but you can see that that's there. Remember, that's just subtracting the 2 values, the 600,000 and the 279. So this is total put in the account. total deposited. And then since I mentioned it, the interest would be 600,000 minus 279,404.69. So the total interest is $320,595.31. It didn't ask us for that, but it could. Interest earned. So the interest earned is money. It's like free money. It's money you didn't have to work for. It just gets added added to the investment with the interest rate. All right, payout annuities. So this one has a new formula, and the good news is you'll repeat using this formula when we do loans. So it's the same exact formula. But it might be interesting to think about why a payout annuity formula is the same as a loan formula. We don't really have anything new in this formula. The letters they all still mean the same thing, but it is a different formula. So just take note that for one thing, we have a negative. Actually, I shouldn't highlight that whole thing, but let me just highlight that negative in the exponent there. So that's kind of new. And we have to be careful about getting all those parentheses right. So that'll be fun. All right, retirement payout. You have $400,000 saved for retirement. The account earns 5% interest. How much will you be able to pull out each month if you want to be able to take withdrawals for 15 years? Oof, okay. This is going to be a beast, so bear with me. I want to be able to see the formula. So 400,000 equals, and then we need to draw a big fraction. On the top, we have D, which we don't know. And then parentheses 1 minus, parentheses 1 plus, R divided by K, 0.05 over 12, because it's each month, parenthesis, negative, and big N is year, so 15 times K, 12. And parenthesis around that, because that is all multiplied by D. And then we divide by 0.05 over 12. Okay, we're going to be seeing this again in the next lecture. So if you don't get it this time, be patient with yourself. Hopefully it'll click next time. What I'm going to do, and you'll see why in a minute, is multiply both sides by 0.05 over 12. Which might seem kind of crazy, but as long as you do the same thing to both sides, you can do whatever you want to an equation. But what happens with that is these are now gone. So now I have 0.05 over 12 times 400,000. Don't worry about what that is. It's all going to come out in the wash. But my right-hand side is much simpler now. D parenthesis 1 minus parenthesis 1 plus 0.05 over 12 raised to the negative 5 times 12. And there's no more fraction. Next, I want to take everything, pretty much everything except the D, because there's nothing I can do with D, and put that in the calculator to figure out what that is. What I just highlighted here is just a number, and we don't know what that number is yet, but I'm going to put that in Desmos right now and figure out what it is. So let me put, I don't need parentheses there. 1 minus parenthesis 1 plus 0.05 divided by 12. Close the parenthesis and then go into the exponent. Parenthesis negative, don't forget the negative, 5 times 12, parenthesis. All right, so I got my answer. I got that it's about 0.22. And yes, I'm rounding on my paper, which is okay. We just want to remember not to round in the calculator. So if you're not getting 0.22, check very carefully, make sure you have the parentheses everywhere you need it. And if you still can't get it, just let me know. We're going to divide both sides by that 0.22, but we're not going to use that rounded value. We're going to use what Desmos has in there. So I'm going to hit enter here in Desmos and then type 0.05. No, we're going to go into fraction mode first. Fraction 0.05 divided by 12 times 400,000. All right, so all of that's going to be in the top of the fraction. 0.05. I just messed mine up, so I'm doing it again. So in the top is 0.05 divided by 12 times 400,000. And then in the bottom, you're just going to click down on the bottom and put ANS because we don't want to round until the end. So I'm getting that D, or the monthly payments to the account, is 7,540. Well, is it monthly? Oh, wow. 48.49. That seems rather high. Yeah, it's not the right answer. 5%, 15, and 12. Where did I go wrong? Oh, I see. I put a 5 instead of a... You know what? You all probably caught that mistake. I had 5 instead of 15. All right, let me just go back and get some new numbers. Sorry about that. I could edit out all my mistakes, but you all are going to make mistakes too, and hopefully seeing me mess up will help you not to mess up. So it's easy just to mess up a number. So it should be negative 15 times 12. But it'll be an easy fix because I just have to go back into Desmos and put a 1 in front of the 5, and then everything is good. Yeah, now I have the right answer. So instead of 0.22 or whatever I had, it should be 0.53. I'm sorry if I was driving you guys crazy, not understanding where you went wrong. 0.53. And with the correct value, the payments are $3,163.17. So that's how much you need to... Oh no, that's not how much you're saving. That's how much you get to pull out each month. That's why it's higher. So you get this much as a payment. When in retirement. As the goal is you'll save some money for retirement, and then you get to just pull out usually monthly payments as your money to live on. So this can be done in Excel with the annuity payout section. And then it'll give you the total that's paid out and how much interest is earned. We got one more example. You want to be able to withdraw $25,000 each year for 25 years. Your account earns 7% interest. How much do you need in the account at the beginning? This is actually a little easier because we're finding the P naught. We know we're pulling out $25,000. That's D. So to be that times, that's the whole numerator part here. 1, I can't remember if it's 1 minus, parenthesis, 1 plus. 0.07 divided by 1, because it's each year, times -1, or up to the exponent -1 times 25. And then on the bottom, 0.07 over 1. So I'm just going to go into Desmos and put all that in. So 20, so I'm going to start with a fraction, and then on the top type 25,000, parentheses 1 minus parenthesis 1 plus 0.07 divided by 1, right arrow to close the parenthesis, exponent, parenthesis, -1 times 25, close the parenthesis and the exponent, close the parenthesis in the top, and then go to the bottom, 0.07 divided by 1. So there needs to be $291,339.58 in the account in order to be able to do that. All right. I'm sure that's long enough. Thank you for your time and energy listening to all this.